the example 6. I'll show you the model prediction for lead lag systems, including the inverse response system. As I mentioned before, we could represent the lead lag system using this transform function. So in this transform function, and tau 1 typically is larger than 3 tau 2, and then this transform function can be simplified by this one. We just keep tau 1 s plus 1 in the denominator, right? Because tau 1 is much larger than tau 2, so the tau 2, this one, get steady state much faster, right? As I mentioned in the class. So now I want to show you in this example, tau 1 equal to 4, tau 2 equal to 1. So you can see tau 1 larger than 3 times tau 2, and k equal to 2. And we want to get a profile for the output, and for tau 3 equal to 16, and 4, 1, and minus 1, right? So since we could simplify the transform function and by this one, right? K times 1 plus tau 3s over tau 1s plus 1. So therefore, to determine whether the system is a lead lag system, we just need to determine the ratio of tau 3 over tau 1, right? As I mentioned, if tau 3 is larger than tau 1, it's lead system, right? Make system faster. It's less than 1, it's lag system. Make system slow down. If tau 3 is less than 0, and this inverse response, right? Okay, now I want to show you and the profile for different tau 3, and then to give you some demonstration, right, for the lead lag and inverse response. Assume that the initial values of y is 0, and at the same time we do a simulation for 30 minutes, and the input have a step unit change, right? A unit step change. So US is the unit step change. Okay. So step 1, we get the transfer function, and for tau 3 equal to 16. So here tau 3 equals 16, right? So we could times these two transfer functions together, right? And as you can see, and the original transfer function should be and 2 1 plus tau 3 over, and here should be tau 1 s plus 1 tau 2 s plus 1, right? Okay, so to input this transfer function in Simulink, the best way is you just separate this transfer function as the product of two transfer functions, right? So now I have, so I take the game 2 out here. Here's the game. This is the game for the 2, right? And then take this one as one transfer function, then this one as another transfer function. So you will get 2 times, here's tau 3 s plus 1 over 4s plus 1, then here's 1 over s plus 1, right? So this transfer function and this step change, and then we add the time signal and save the time signal into the workspace, right? Save the output signal in y1, right? And then similarly, we could get the tau equal to tau 3 equal to 4, tau 3 equal to 1, and tau 3 equal to minus 4, right? So and then we also change the y2, y3, and y4, right? And then we do a simulation for 30 minutes. Okay, now I want to show you how to do that in Simulink. So we add file, new model. Then we close this one, and then we save it as a Simulink. And for example 6, and then so we add the transfer function first, continuous transfer function, right? Zoom in, and then we have two transfer function times together. So the first one is here is 16 for tau 3 equal to 16, 1, and then here's 4, 1, right? And the second one is 1 s plus 1. So this one we don't need to do anything. And then we add the step source. Here we get step here. At the same time, we also add the time signal, right? The clock. Okay. And then this is unit step change, so this is 0, step time 0, initial value is 0, and final value is 1. Okay, so this one is done, but we need to get the game 2, right? Because in the case is 2, so we add the game here is mass operation. The game here, the game is 2, and then link them together, and then we're done with the first one, tau 3 equals to 16, but we need to record the output, right? Here is go to sync, record the output to the works, record output to the workspace. So change the name to the T, right? And then as array format, okay. And then similarly, we could get a workspace for the output. Here we change to Y1, and then again the format is array. Make sure you know this, right? Array, okay. And then we could add the scope and to monitor the dynamic of the output, and then we'll also use display to show the start state. Okay, now we're done with tau 3 equal to 16, and then we want to copy this one. Well, here we don't need to copy the clock, right? Because the clock is the same for all of them. So we just copy this module transfer function, right, for transfer function for other 3 tau 3. And then with this one we change tau 3 equal to what? To 4. So tau 3 instead of 16 equal to 4. Okay, and then this change to Y2, very good. And this one we change tau 3 equal to 1. Okay, this equal 1. And this one we change to Y3. Y is in array format already. This tau 3 equal to -4. -4. And then this one change to Y4. Okay, and then change simulation time to 30 minutes. Right? Then save it, and then run simulation. See, the simulation is similar. Start state 2, 2, and 2 and 2. The start stage is not changed because the game is not changed, right? Okay, now let us plug the profile together, right? And then just type all this command into a main function. Here is this command. Right now, let me work together. Let us work together. So here, just click the plus and icon, and then to build a new function, new script. So type T Y1 red color and light width 2. Right. Save it. So Control and S together. This means 6. Right, and then just hold on, right? And then you could copy this for Y2 and Y3 and Y4. Right, so we have 4 profile. But for the last one, we don't have hold on, right? For the Y4. So we change this one to Y2. And then we change the blue color. B is blue color. And then this Y3. And then we change to the for the K color. And the K is the black color. And then the last one is Y4. We might use the actually we should here there's some typo, so not this should not be K because this is the same black color. We use, for example, we use green color. G is for green, right? Green color. And then as label, almost there. As label, time and minute, and then font size 12. Similarly, we could get Y label, and here we get Y, and there's because this just shows function no unit here, and then we need to get a legend. Legend here we want to put tau 3. Here is, you can see tau 3. This one, this part slash tau, and this means this represents the Greek and symbol tau, and then here underscore 3 means what? This means subscript 3. Okay, so therefore we get tau 3. Now legend and slash tau. Okay, and then subscript 3 equals 16. Right, and then come on, right? Then just copy this for tau equal to 4, 1 and minus 4. Right, here should be, you change this one to this should be minus 4. Okay, so 1, this would be 4, this would be 1, this should be minus 4. Right, and then you have font size 12. Okay, then save it, Control plus S, then just run. Then example 6. Okay, see this profile we should get. This should be green one, the green color. This for minus 4. Okay, and you can see here the profile. Right. So this one is for tau equal to 16, tau equal to 4, tau equal to 1, tau equal to minus 4. See, this is a leak system, right? Right. This is this tau 3 equal to tau 1 equal to 4. So this they just cancel, right? These two just cancel. These two just cancel. So this equal to 1. So no, not leak, not lag system. This normal normal condition, right? Then this one's a lag system. This one minus, right? Tau 3 equal to negative value. So this have inverse response, right? When tau 3 is negative value, is negative. Okay, we are done with example 6.